Okay. As I was saying, this is me. My name is Benga. Nothing much about me. I'm just a data guy, a humble one. And what makes me happy is seeing everybody happy. See people achieve their dreams, their goals. And that was one of the reasons why we started this Power BI challenge. Uh, you know, it's just a way of contributing to the community as a whole because we have a lot of enthusiasts that are in the different groups that we have. And the major point is for us to just grow all together, right? Now, the agenda for today's session is that we want to introduce Power BI. So it doesn't matter whether you are still a starter or you are uh, or you use Power BI for a long time. There's a lot of case study topics that are embedded in this challenge that I believe that even me as a person is going to help me when I hear from other people, right? So the basic agenda for today's session is to understand the basic concepts like data analytics, data visualization, and business intelligence. Understand what Power BI is and some of the numerous functionalities embedded in Power BI, right? And also understand how you can build a very simple report with Power BI, right? Okay, let's move to the next thing. Please, can you all see my screen clearly? Can you see my screen clearly? Okay, thank you. Thank you, Chidima. Okay, now what do we need to know? What do we need to know? What is Power BI? So we are going to be discussing Power BI as a business analytics tool, right? We are going to explore different data sources that you can integrate with Power BI, right? For example, your file data, your database data, your Azure data, online sources, other data, blah, blah, blah. We are going to be looking at different types of views we have in Power BI, right? We are going to be exploring the building blocks in Power BI. We are going to be looking at one very important thing to know, primary and foreign key. We have to understand the difference between primary and foreign key. We are going to be looking at what is data model in Power BI. What do you mean by when we say we model data, right? What do we mean by cardinality of relationship? We are going to look at all of these concepts. We're going to explore the common charts we have in Power BI and also explore some basic DAX, right? So the class for today is just the introduction. It's not as if you are going to be going in depth into all of these things, right? The other stores are coming, and you are going to be the one giving detailed explanation of different kind of functionalities that we have in Power BI. Now let's move on. Now, Power BI overview. Now, Power BI, we can define Power BI as a business analytics tool. It means that Power BI is a suite of business analytics tools that deliver insights throughout your organization. It means that with Power BI as a business intelligence tool, as a business analytics tool, right? You can use Power BI to deliver insights throughout your organization. So what do we even mean by insight? Let me ask you. Can anybody raise up their hand? What do you understand by the word insights? Anybody? You can raise up your hand so I can just unmute you. Can anybody try? Oh, Bala said detailed information. Thank you for that. Any other person? Insights. What do you understand by insights? Any other person? Okay, if there's nobody, no problem. So insights is, okay, somebody wants to say something. Priska. Okay. Yeah, you can unmute yourself now.
Okay, good afternoon, good evening, everyone.
Good evening,
okay, insight can mean deep understanding, clear view.
Okay.
Yeah.
So clear view, deep understanding. Can you give me like an example that I can work with?
Okay, when I say a clear view, you want to know, it helps you to know more by easily looking at it, not by easily looking at the results that you've gotten. So you just, by looking at it, you can interpret one or two things from what you have done already.
Okay, so you mean like an in-depth view of your analysis is what you mean by
yes.
Abi? Okay,
Yes,
thank
yes.
you for that. Thank you very much. Okay, let me see the other comments. Valuable information, unusual information not visible to the eyes. Okay, some hidden info you can't see at a glance at first. Okay, good. A piece of information, knowledge that helps us clarify or solve a problem, in-depth knowledge. Thank you, everyone. Thank you for your comments. Thank you. I appreciate it. Okay, now let's move on. Now, when we are defining the concept of Power BI, it's also good to also note that Power BI can connect to hundreds of data sources, right? When we say hundreds of data sources, it means that there are so many data sources that we can integrate Power BI with, that Power BI can pick data from, right? Or can grab data from, right? Another good thing about Power BI is that Power BI can simplify what is called data preparation. Now, let's explain it in the context of how we can understand it. So when we say data preparation, what we usually mean is data cleaning. That is, Power BI as a tool allows you to prepare your data for analysis, which involves you cleaning the data, right? By, for example, changing your data type, removing null values, writing some calculations to give you extra columns, a whole lot of all of those processes, right, is data preparation, right? Now, Power BI allows you drive ad hoc analysis. What does that mean? It means that there are some analyses that are not originally embedded in your data that Power BI can help you because of the way it is built, because of the kind of functionality that is embedded inside it. It can help you drive ad hoc analysis, extra analysis, insightful analysis, right? Now, with Power BI, you can produce beautiful reports, right? I've seen if you go on Google, for example, you'll see a lot of when you type Power BI inspirations on Google, you will see a lot of Power BI report that people have built in the past. A lot of sorry, very beautiful reports, colorful, with a very good look and feel, right? People have built a lot of stuff with Power BI, a lot of stuff, and those are the things that really, motivate people to say, oh, let me replicate this. I can do something like this, right? So with Power BI, you can build your report the way you like, right? Use the use of colors, the use of backgrounds, your design, your layouts, your theme, all of those things. You can use Power BI to build a lot of fine reports, right? Now, a good thing about Power BI is that you can publish these reports, right? Whether on the web, whether on mobile devices, so that people can consume your reports. So it means that in every organization, everywhere you find yourself, there are people that the report designers, and there are those that are report consumers. Some are designing the report, some are deploying the solution, some are building this report. Some people are doing what they are the ones consuming this report. When we say consumption, it's not about food. Consumption in the context of they use those reports that somebody built to make decisions, right? To influence operational efficiency and do a lot of other things like that, right? Now, Power BI is a self-service application. What does that mean? It means that everyone can create personalized dashboards with a unique 360-degree view of their business. Like this, with Power BI, you as a person, I can build the reports the way I want to build it, based on the context of my understanding of the data, of the business, my understanding of the business requirement, the business need. I can build a personalized report or dashboard, right? And Power BI can give me a 360-degree view of my business. It means that Power BI can touch every area of the data. It can really explore the data, depending on how much you know how to use Power BI functionalities, right? One thing about Power BI is that it can scale across enterprise with governance and security built in. So Power BI has governance and security built in. Now, if you look at these four boxes down here, you will see these four things. Has anybody heard of Power View before? Power View. Anybody? Have you heard of Power View before? Somehow, somewhere on YouTube, anywhere. Anybody? Power View. Power View. Oh, somebody said no. Okay, no. So yes, so Power View was developed by Microsoft, and it used to be a hardening in Excel, right? If you look at the Power View interface, it just looks like Power BI, but it's like a lower version of Power BI, right? You can use it to build your reports and dashboards. Or somebody said yes, okay, and dashboard and bring in some charts to do one or two things. Yeah. So Power View used to be so it's not as if Power View is like not in existence anymore. Power View is still available, but is they really declare or let me say they really like they've reduced the way people use like they're not really developing it or anything. It's just there, right? So we have Power View. So these are like the four things that makes up Power BI, basic things. So it's not like these four are like the everything. No, just like the basic things that makes up Power BI, right? We have Power View. We have pivot table. Anybody knows pivot table in Excel? Pivot table. Anybody? Pivot table. It's not how you know Excel. You don't know pivot table now. Right? So pivot table, very popular stuff, right? We have Power Query, right? That we use for data preparation, data cleaning, calculated columns, all of those. They are all from Excel, right? We have Power Pivots. Anybody have you heard of Power Pivot before? Power Pivots, Power Pivot, guys. So Power Pivot in Excel, is that interface where is that engine, right? Where you do your data model, you connect data tables, one table to another table, based on the cardinality and based on, the whether it's a dimension or a fact table. Don't worry, we'll still go into all of these things in depth later, right? Let's move on. Now, Power BI and data sources, right? When it comes to Power BI and data sources, then we talk about, for example, we have file data. Under file data, we have stuff like your text file, your JSON file, your XML file, your CSV. The Power BI can connect to all of these file data. When it comes to database, Power BI can connect to your SQL database, your IBM DB2, your Microsoft Access, a whole lot of different kind of databases that Power BI can connect to, right? Power BI can connect to Azure products, Azure data products like your Azure Start Analytics, your Azure SQL database, and a whole lot of other Azure platforms like that Power BI can connect to source for data, right? We have the online sources, we have the other sources like your web. So if there's a website, Power BI can connect to that website and pick data from that website. So there's a lot of all of these different data sources that Power BI can connect. So these are just a few, right? Power BI can also connect to your Power Platform. Power Platform is your Power BI, your Power Apps, your Power Automate, and other ones that are there. We're still going to explore them in depth, right? We have some basic views in Power BI. So this is just like a few. We have report view, or we also call it report canvas, where you build, your reports, where you bring in all the visualizations and you do a lot of beautification to your reports. You do all of that on the report view. And your data view is like the table view, right? Where you will see your data in terms of rows and columns, just like what you see or what you have in your Excel, right? We have the model, or you can call it the relationship view. That's where you do your data model, you connect, different tables to each other, right? Now we have the DAX query view now, where you can write your DAX formulas, you can query your data and see what the result is going to look like, right? And we also have the Power Query view. This is like the fifth one, where you can do a whole lot of transformations to your data and stuff. Okay. Now, the building blocks in Power BI, the building blocks in Power BI. Now, Power BI, for example, when you are building a house, I always use this as an example very well. When you are building a house, what's the first thing? You have for your foundation, you start building from foundation upwards. To get to a time you get your lintel level, you have to do lintel before you do your roofing. So that's the way it happens in Power BI. So Power BI too, building a report or dashboard in Power BI too as a process, right? It means that the first thing is for you to get your data sets, right? To understand where exactly are you connecting to get your data sets, right? And when you do that, you do a lot of transformations and everything. Then the next thing is visualization, right? You visualize your data. right? For example, you use your bar chart, your line chart, your column chart, your card chart, and all those kind of different kind of charts, right? And after visualization, what we have is tiles. Now, tiles is that thin line that encompasses your visual. That is when you over on your visual, you're going to be seeing like a tiny gray line. Sometimes it's always gray, right? That captures that visual, that makes that embeds that visual, right? So that thin line is called tiles. Now we have reports and we have dashboard. So I'm going to be explaining this in the context of Power BI. So when we say reports in Power BI, if you open your Power BI desktop, for example, you're going to be seeing the different reports page 1, reports page 2, blah blah blah, and all of those. Now, uh, by the time you publish your reports on Power BI service, for example, you publish your reports and uh, you publish that report here on Power BI service, then you can build your dashboard from your Power BI service. It means that you're going to be picking tiles from all of the different reports you have, and put all of that in the dashboard. It means that when we say dashboard in the context of Power BI, it means that that's like the most important report to the stakeholders. It's what is called a dashboard, right? Reports can be any kind of report. You can have procurement report, you can have sales report, you can have customer service reports, you can have logistics reports, we can have warehouse reports. Picking the most important from all of these different reports, in a place is now what is called a dashboard. Somebody was raising up their hand now, Joyce or something. You want to say something? You can unmute yourself now, Joyce. Hello? Oh, I'm too fast. Oh, sorry about that. Sorry about that. Okay, I'll take it slow. I'm just trying to be time conscious. Yeah, I don't want us to pass the 1 hour. That's why I'm trying to be fast. Sorry about that. Okay, let's move to the next thing. I'm going to be explaining this with example, right? I'm going to be explaining this with example. The primary and the foreign key. Before I go to this, please, do we all understand the building blocks from data sets to visualization to tiles to report and dashboard? Do we understand it, guys? Please, I want your comment in the chat section. Okay, most people are saying yes, they understand. Okay, thank you. Thank you, thank you, thank you. Let's move to the next slide. Okay, let me explain the dashboard part very well. So what dashboard means is that dashboard 2 is a report, right? But it's like the most important report. So for example, in an organization, the CEO wants to see uh, your performance in terms of procurement, in terms of sales, in terms of logistics, and all of those kind of different departments have their own KPIs, right? But the most important reports to him might be the profit margin, the uh, so how many customers are you on budget? So the customer growth, the customer engagement, profit, sales, those can be like the most important reports to him. So we put all of that in the dashboard, right? So we can have different kind of reports, but the most important report to stakeholders is what should be embedded in dashboard. Do you understand it now, Chidima? Do you understand it now? Yeah, our customers are satisfied. Yeah, those are good examples. Yeah, thank you, everyone. Okay, now listen to the concept of primary and foreign key. Can anybody explain it? Have you heard it before? Just explain the way you understand it. I want the class to be interactive, though. Just raise up your hand to something that can unmute you to say something. Primary and foreign key. How do you understand it? Chidima wants to explain. Let me unmute you. Yeah, you can talk now, Chidima.
Okay, sir, thank you so much for your time. Actually, primary key is like a unique identifier, while foreign key is like a reference table. We have a reference from the primary key, something like that. But the
Can you come
primary
again,
key,
please? Can you come again, Chidima?
okay, the primary
Okay.
key is a unique identifier, while the
Okay.
foreign key is like a reference key. We have a reference from the primary key.
Okay, thank you very much. Can you explain to somebody that is a layman?
Okay.
Because almost all of us that are here, it's not all of us that know Power BI very well, understand this concept very well. So explain as if
Okay. A primary key is like as in a unique identifier, like you having one unique number. Like now, your account number now is your unique number owned by only you. So that's the primary key.
Okay. So what about foreign key?
Then the foreign key is like a reference. Like now, if you want to reference a table that has a connection with the primary key, so there's no point writing the table like that. You just reference it from the foreign key. Something like, I really don't know how to put it together in words. But I think that's what I'm saying.
Thank you. I understand. Thank you. Okay,
Right.
so now people who want to talk, Rachel Abulu, you can unmute yourself now.
Yeah, sir. So for the foreign key, I think she explained the primary key very well. For the foreign key, I would say it's let's say it's a field that is present in both tables. So you can find it in both the table that has the primary key and the other table, so that you can use it to like link or join tables together. So that's the foreign key. So it's present in both tables.
Okay, thank you. Who again will say something? Okay, Rachel just spoke now, right? I'm coming. Some people are raising up their hands. Okay, I have Mariam Gbemisola. Okay, can you unmute yourself now? Mariam Gbemisola. I can't hear you.
Can you hear me? Good afternoon.
Good afternoon.
Good afternoon, everyone.
Good afternoon. Good afternoon.
All right.
Yeah, go ahead. Go ahead.
All right. So for the primary key and the secondary, the foreign key.
Yeah.
The primary key. Can you hear me clearly, please?
I can hear you clearly. Just continue.
So the primary key and the foreign key, they are both unique identifiers. But the difference between the primary key and the foreign key is that you will only find the primary key in a dimension table, whereas you find the foreign key in a fact table. So primary key and foreign key, they are used to as a connection, as a unique identifier to connect the fact table to the dimension table. So another thing is that primary key is unique, and the foreign keys, they have duplicates, because most of the time when you are visualizing, you have need to create a kind of relationship between these tables. And so the foreign keys are always having duplicates because they are always on the many sides of the table, which is usually the fact table.
Thank you very much, Mayor Mbisala. Thank you very much. Thank you. We have some people raising up your hand. I've been Bola Falano.
Good evening.
Good evening.
I would like to use the example she used for primary when she talked about account number. To the best of my knowledge, I would say foreign key is like a table that contains all the records of account numbers for customers that you have. And from that table, if you want to make reference to a particular account, a particular customer's account, which is the primary key where she identified, you reference it from that very table.
Okay, can you re-explain, please, in simple terms?
Okay, I said foreign key is a field that contains, it's a table that contains account numbers of all the customers you have in a particular bank. And if you want to make reference to the particular customer who is the primary key that she talked about, it is the connection, the foreign key is the one that links that table to the primary key. Okay. I don't know if I was able to explain.
No problem.
That's the best way I can explain. Thank you.
No problem. Thank you. Okay, TG, you can unmute yourself. TG, let's be fast, please. Okay, Frank Billionaire. Continue, Frank.
Good evening, sir. Good evening, everyone.
Yeah, good evening.
Yes, just like everyone has said, everyone has contributed rightly, but I would just like to just give an instance based on what everyone has said.
Okay.
Yes, foreign key we have primary key and foreign key. They are all both a unique identifier. But primary key in a customer table, customer ID is a primary key in a customer table. Then if you are dealing with customer table and other table, order ID is a primary key in an order table. If you now see an order ID in a customer table, that order ID becomes a foreign key in that customer table. Why? Because customer table is not the original table for order ID. Its original table is an order table. But because it found itself in a customer table as an order ID, becomes a foreign key in that table. Meaning that if you are in Nigeria and you find yourself in Canada, because Canada is not, you are not a citizen of Canada, your country is Nigeria, you become a foreigner in that land. Why? Because that is a new land you find yourself. So that's the same way, that's an analogy I will use.
Why?
Boss, I'm not replying to you, sir.
Okay, don't worry. Thank you.
All right, thank you, sir.
I'm still going to correct some things though. People said some very funny things, very funny explanation, but I will still come back to everybody's explanation. Okay, let me give Kafayat Ibrahim.
Well done, sir.
Well done.
From my end, I would actually like to use the scenario of the account number we used earlier. Let's take our primary key on our account customer accounts, like customer account name as a primary key. But when dealing with transaction, that is when the bank is actually dealing with the transaction and they are asked to fetch like the transaction details from their database or from the table given. So the customer account number on the account details now a foreign key on the transaction details, because now they'll be looking at all their customers with they'll be looking at all their customers in respect to the transaction, why the transaction is actually the primary key on that particular transaction table. Thank you.
Wait, don't go yet, please come back. You said the account number
yes, sir,
is the primary key on the customer table, right?
Yes.
But when it gets to transaction table, because that primary key that account number will show several times, it now becomes a foreign key on that table. Is that what you're saying?
Yes, sir.
So what do you mean by transaction table? Because let's explain this thing, like all of us that are here, we are new to this thing. So what do you mean by transaction table?
What I mean by transaction table.
Yeah.
Well, let me give an instance, like a loan in the bank.
Okay.
So we have a customer. While opening an account for our customer, they will actually have a name. All of them will have a name.
Okay.
And yes, and with that particular name, that will actually be on their customer, like customer names. So when dealing with the loan, they will be dealing with another table entirely. That will be given the loan ID and the customer accounts information. So the customer can actually come once or twice for the loan.
Okay,
yes.
so that means
and the transaction ID
information will be showing several times on that loan table.
Yes, why the transaction ID will only will be indicated there once.
Okay, no problem. Thank you. Thank you for your try. Okay, Sam Sarini, last person I will allow before I move on. Sam Sarini.
Yeah, good evening.
Good evening. Primary and foreign key,
Yes.
sir. Let's be fast.
Okay. Primary key is a unique identifier.
Okay.
Is when you have a table, a unique identifier.
Okay.
So when you have a table, a particular column or a particular variable that specify what this particular row is all about. For example, in a class, we have a matric number. Matric number of student can be a primary key because a matric number is meant for only one student.
Okay.
So now, foreign key comes to play when you have two tables. For example, let's say we have courses and we have course code. So in the table for courses now, the course code for the table is still primary key because one course we have one course code. But when we are trying to relate students with courses now, in a student table, course code will now be a foreign key and a foreign key to the primary key in the course code. I think my explanation is
how is it going to be a foreign key on the student table?
Because five students can offer a single course.
Because 5 students can offer a single course. Okay.
Continue. Yes, and so we can use the primary key. The primary key.
You know this is about course code. This is about course code now.
Okay, about course code. Is the course code is still the primary key in the course table.
When you get to the course table,
so when you now
get to the student table, go.
Now, when I get to a student table, it becomes a foreign key to connect it with the course code. To connect the student with the course code, it's
Why
now
is
a
foreign key on the student table? That's the question now. How is the course code now a foreign key on the student table?
Because it is a let me call it, is a variable or a column that we use to reference another table to connect the two tables together.
Okay, no problem. No worry. Thank you. I appreciate it. Thank you. Okay, Miriam, our mathematician. Miriam, are you there? Please kindly unmute yourself.
Okay, all right. Yeah. Good evening. Sorry, I just joined late, but I met the conversation of primary and foreign
key. Yeah.
So there's one thing I would like to say. I can use the example of the course codes.
Okay.
So the course code, like everybody said, is a unique identifier. So it's cannot, one course code is associated with one particular course title. It cannot change.
Yeah.
But when that course code goes out into another table, let's say a list of students and the courses they take.
Okay.
So when that primary key, that course code goes into the other table, it becomes a foreign key. So anytime a primary key goes away, when it's not home and is away, the name is going to be foreign. But if it is at home in his own table, it's residing in his own table, it is a primary key. So when it goes away, it can be associated to many records, to many individuals.
Okay.
So it becomes a foreign key because a lot of students can take one particular course.
Exactly. That's what I was looking for. Thank you. Thank you.
All right.
I appreciate it. Thank you. Adiola wanted to say something. Adiola Juliet, the other time. Can you unmute yourself now? You're the last person I'm taking. We'll have to continue. Adiola. Adiola Juliet.
Good afternoon. Can you hear me?
Good afternoon. I can hear you. Your background is noisy.
But in this case, I can't keep taking. Oh, sorry. I can't keep taking.
Because I just wanted to. Let me just mute you, or you say it on the chat session. Is that fine? Or
okay.
Is the background okay?
No, it's fine now. It's fine now.
Okay, continue.
I just want to I just want to add a contribution to what everybody is saying. I think they have a point, but to my own understanding, I just know that a primary key doesn't have a duplicate. It has to be a specific number, a unique number, but it will make a reference to other table, which is the dimensional table, while the primary key will remain the constant. So maybe we have a fact table somewhere else, and we have a dimensional table. So which the dimensional table contains the qualitative aspects, while the primary key may contain other quantitative or qualitative. So we have to make reference to both tables to have a connection between each other.
Okay,
so
no problem.
that is what me I understand. Thank you.
No, thank you. Thank you. Akin Jolly Bolaji.
Good evening, sir.
Good evening, sir.
Oh, so I think everybody have make a vital point. It may just come again. It's just a let's say repetition. But one thing that I would just like to add is that the example that one of the contributors said that if we are in Nigeria, when you are at home, you are the primary key. I think that's the best explanation that I enjoy most. That
You
actually
enjoy that because you mentioned Canada.
Maybe something like that. So we can just move on. Thank you, sir.
Thank you, everyone. Don't let me allow anybody again. Thank you, everyone, for all your examples. Okay. So I'm going to be explaining primary and foreign key. See, when I teach, I like to give practical examples, right? For the sake of people that are here that don't really know all of this stuff. They are new to Power BI and like completely. They don't have an idea. Okay, let me do this. I'm going to, okay, let me close this one. Just hold on 1 minute. I'm going to show us something now. It's the best way of explaining all of this, right? Let me stop sharing and share again. Now, let me give you a practical example. I'll be using sales example. So, for example, we have 3 tables. Look at my screen, guys. Can you see my screen, guys? Sales table. That's the first table we have. We have customer table. Let me know if you can see my screen or not. So we have customer table. We have product table. Let me stop at the product table, right? Now, on my customer table, which I have here, at this corner here, I have my customer ID, course ID. I have customer name, right? What again? I have customer, maybe gender. And what again can I have my customer table? Let's say I have what again? Give me ideas, guys. Customer ID, customer name, customer gender, customer address, right? So I have customer 101, I have customer 102, I have customer 103, I have customer 104, I have customer 105. I have customer name. I have, let me put my name. I have Benga, I have Easy, I have Femi, I have Adiola, I have Miriam, right? Customer gender, Benga is a male, female, right? Customer address, I have Nigeria, I have Canada, I have UK, I have Australia, I have Germany, right? So this is my customer table. So every customer has their own customer ID. So Benga and Femi's ID will be different because they are 2 different unique individuals, right? Right? Okay. That is for the customer table. Now let's go to the product table now. Let's go to the product table. Let's go to the product table. What do we have on the product table? We have, of course, product ID, of course. We have the product name. The product name, right? Okay, so on product ID, we have product ID Y12. We have product ID Y13. We have product ID Y14. We have product ID maybe Y15. Okay. Now the product name we have, we have oil, we have cookies, right? We have bread, right? We have what again? We have paper, right? Just an example. So every product has their own unique IDs, right? Oil, bread, cookies, paper, whatever. Now let's now move to the sales table now. That's our transaction table where we have all the transactions going on, right? On the sales table, we have the order ID. That is, everybody bought something. Every order is a unique order, right? We have the order ID, right? And on the order ID, we can have order ID 10022. We might have order ID 10023. We might have order ID 10045. We might have order ID 100, maybe 1078, something like that. We might have order ID 10095. For example, right? Now I have, so there's an order. Of course, somebody bought the order, right? So we have the customer ID on this table. Let's say Benga bought an order here. Let's say Eze bought this. Let's say Femi bought this. Let's say Miriam bought this. So let's say Benga bought again. So we have Benga appear 2 times, right? Okay, now let's say the product now. So on every order, there must be a product that was bought now, normal, right? So let's say we bought Y15 was what was bought, that was the paper. We have Y13, right? We have Y15 again, right? That means that product was bought 2 times. We have Y12, right? And we have Y14. Now, guys, can you see my screen very well? Now, this is where we are going to. Now, we have 3 tables in our database. We have the product table that is a dimension table. We call this kind of table dimension table. It's because it contains unique values. What do I mean by that? If you look at your product table here, we are only seeing every unique product. That is, oil is Y12, cookies is Y13. So it means that cookies will not have 2 different IDs. It will only have 1 unique ID because on its own, it's a unique product, right? Bread itself has its own unique ID, is Y14. Paper has one Y15, right? Now, for customer table too, it's a dimension table because this table we call dimension table, they uniquely talk about a particular event or a particular thing. So what do I mean by that? So when you get to product table, you only see information about product alone, right? When you get to customer table, you are only going to see unique information about customers alone. So you will not find anything about product on the customer table, and you will not find anything about customer on the product table. Please, is it clear to us what I'm saying from here? Is it clear to us, guys? Because I want your responses. Is it clear? Thank you. So we call this kind of table, the product and the customer table, we call them dimension tables. Dimension tables. Let me wrap this. Yeah, we call it dimension tables, right? Because they uniquely talk about a particular thing. Product table is all about product alone. Customer table is all about customer alone, right? It will talk about customers, and I'll give you a unique list of all of these guys, right? Now, let's now come to the sales table. Now, on the sales table, you are seeing the order ID. It means that one order is a unique order. That is one order, one unique order ID, right? Now, you see that is a customer code, a customer ID 101 is appearing 2 times. This customer, if you look at the customer table, this customer name is Benga, right? And you see this customer bought, had 2 transactions, right? 2 times he bought something. He has 2 unique, 2 different orders, right? Order ID 10022 and order ID 10095. This customer bought something 2 times on the sales table. Now, this customer on its own original customer table, which is a dimension table, right? This customer ID is a unique ID. It's a primary key on this customer table because the primary key only have unique lists and no duplicates, right? Now, by the time this customer ID now gets to the sales table, which is a fact table, Now this customer ID becomes a foreign key on that table. Because number one, the customer ID is not its own original table. That's number one, right? That sales table rather is not its own original table, right? Secondly is that there's a possibility that the customer ID, which is unique on the customer table, becomes duplicates on the fact table, on the sales table. Because it's not possible that one customer will buy something once and that will be the end of it. It's not possible. One customer will always come around to buy stuff, like almost at different kind of frequency, right? So the customer ID on the sales table, on the fact table, is a foreign key. But on its own original table, it is a primary key. Please, is it clear to us, guys? Now, let me go to the example of the product table now. So we have a product table that has a list of all the products, unique list of products. We have products that these are like 4 products here, right? And on their own table, you see that it's unique, right? You want one product, one unique ID, one product, one unique ID, another product, another unique ID, right? A unique list. Now, the product ID is not possible that one customer or at one product will only appear at one transaction. It's not possible, right? That's why you see that one product ID will occur more than once. It can occur several times. So on the product table, the product ID is a primary key on its own original table. By the time this product ID gets to the sales table, or we can call it the transaction table, where all the transactions, the activities of sales goes on, right? It becomes a foreign key on that table. Because number one, that is not its own original table. Number two is that it has duplicate. There's a possibility of duplication because of the frequency of times that particular unique product was bought, right? So that is what we mean by primary and foreign key, right? And also, I've also explained stylishly what we mean by dimension table and fact table. So when we say fact table, this is the six table we are using the example here, is a fact table, right? Because it contains everything we want to analyze is there. All of the measures is there. All of the metrics is embedded inside the fact table. Please, do you have any question going forward before I go to the next thing we have? Any question so far on primary and foreign key fact dimension table? Anybody? Any question? I assume there are no questions, right? Okay, thank you. Now let's move to the next thing. Okay, Bolaji wants to say something. Please make it fast. Make it fast. Oh, it's not okay, it's just thumbs up. Okay, thank you. Okay, now let's move to the next thing. Let me stop sharing. Our time is fast spent, so we have to be very, very fast. Very, 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 very fast. Let me go back to my slide. Yeah, so let me move fast. So primary key is a unique identifier, of a record in a relational database, while the foreign key refers to the field in a table, which is the primary key of another table. So a table can contain only one primary key, yes. And for foreign key, a table can contain more of one foreign key, right? Now, primary key, again, you say that no two rows can carry duplicate value of a primary key attribute. It means that in the example I gave, it means that two products cannot share one ID. It means that two customers cannot share one ID, right? When we say primary key, we talk about uniqueness. That's one of the features of a primary key. Now, a foreign key can have duplicate values. A primary key does not allow non-value. It means that you can't say a transaction happened, right? For example, in the sales table, and there's no other ID. It's not possible. There has to be an order. Even if there's no eventual stage, there has to be an order, right? So, for example, you can't say that, for example, in your gender table now, you have male and female. You now said for male, there's no unique ID, but for female, their unique ID is 102. It's not possible. A primary key cannot be null, cannot be empty, right? A foreign key can be empty. You know why? Can be null. you know when this can happen. For example, let's say that one that I used. Somebody can, create an order, maybe maybe for example, on an e-commerce application, right? And you can just create an order and not put any product there, maybe by mistake or whatever. It can happen. So it's very possible that your foreign key will be empty. It's very possible. If there's no eventual sales at the end of the day, you might just have an order ID, but there's no product attributed to the order. It's very possible. So that's why we say that the foreign key can contain null values. Let's move fast. Now, I have to go back to that Excel file now, right? Because of what I'm about to explain here. So here's what we call cardinality of relationship. Okay, we've talked about fact and dimension tables. That one is clear to us now, I believe. Now let's talk about cardinality of relationship. Now, we have two types of cardinality of relationship. We have one cardinality and we have the many cardinality. Now, what do I mean by one cardinality and what do I mean by many cardinality? Now, let's go on a very short break. Let's go on a 4 minutes break. And when we come back, we are going to quickly explain what we mean by one cardinality and many cardinality, and also maybe explain and also finish the other stuff we have here. So we are almost through. When we come back on the 4 minutes break, we are going to quickly use like 10 minutes more to explain what the other stuff we have on the slide. Then we call it a day. I'll meet next week. So 4 minutes break, guys. So let's come back in the next 4 minutes and we continue the class from there. If you have any comments, please just put it on chat section. Thank you. Hello, guys. Welcome back. Welcome back. Welcome back. Welcome back. I'm going to be sharing. Just hold on for me, please. I'm going to be putting a link on the chat section now. Please fill the attendance form. Very, very important, guys. The attendance form is very important. If you don't fill this form, it means that you are not going to get the link and the mail for the next class. So it's very, very important. So let's do that in 1 minute before we continue. Please fill the attendance form. I sent it on the chat session just now. The attendance form, very important. Fill the attendance form in 1 minute. Okay, let's continue so that we can finish on time. We are almost done, so that everybody can go and rest. Okay, so I was explaining cardinality of relationship to us. Cardinality of relationship to us. Now, let's use the example of your dimension table. You don't forget that on the dimension table is a table that has a unique list of, of all the stuff. Oh, Ayobami is saying something. Okay, Ayobami, can you let me unmute so you can contribute to this? I think you're talking from the aspect of a database person, but this is just Power BI anyway. So let me allow you. Ayobami, you can continue. You can unmute yourself now.
Mr. Benga, good evening, everyone.
Well done, sir.
I didn't want to interrupt your session, actually.
No, sir. Continue, sir. You are my organa. Who I be?
See this man.
Continue.
Okay, thank you for the opportunity, right? So, speaking about primary keys and foreign keys, like you had explained, you have shown everybody in the house on the call. The primary key column is unique in your dimension table. Then in your facts table, which is your transactional table, there's a field for the foreign key reference to the dimension table. However, at the point of building or modeling your database, it's the responsibility of the person actually building the database design and model to actually put into consideration the relationships between both tables and establish, so there's a constraint you could implement when building both tables, such that, as a matter of fact, you don't even necessarily need to enter the value into the foreign key field in your fact or transactional table. It automatically picks the value directly from the dimension table into that column. So if that is properly implemented, there will be no situation whereby a record will go into your facts table and the foreign key reference will be null. Rather, that record will not go in. It will throw an error on the application that is trying to insert the record, that a referential integrity constraint is being violated, and as such, that record will not go into the facts table. But because many times people don't do all of these proper database design techniques, you eventually find yourself trying to analyze data that has issues, and because these constraints are not implemented, you then get to see null values in your foreign key field, which at the point of analyzing your data now, you have transactions on dimensions, maybe a product or a customer that is not in your dimension table. Then on your modeling or your report, you now have to see, when you try to analyze by the dimensions, you now get to see some going into a blank body. So you see all of the product categories, all of the product brands or something. Then there will be a portion that will be blank. So I know people doing reporting would have always come across a number of blanks when they try to do the analysis on Power BI. So those records in your facts table that don't have a reference in the dimensions, that have nulls, would all fall under that blank grouping. Let me just put it that way. And you can't make sense of them because you don't know which product they belong to. You don't know which customer they belong to. Then it becomes an headache for the analyst, because how does it interpret that information to the business? So those are just little things that developers need to put into mind when modeling, building their ER diagrams and all of those things, so that they make the work easier for the analyst on the long run. So that's just my little contribution. Thank you.
Thank you very much, Mr. Ayobami. I hope we all understand what Mr. Ibami is trying to say, that in the normal context, a foreign key value also should not be empty, right? So the reason why I just said that point is that he is coming from the angle of, a database design person, somebody that knows, that has a good understanding of database design, database architecture, right? So it means that, for example, when you make an order, even though that order might not eventually become sales, it means that the product should still show, right? It should reference from the primary, from the dimension table, even though the amount part might now be 0, but at least there should be. So yes, it's possible. But the only reason why I just said it in that, as part of that, comparing when I was trying to do primary versus foreign key, is that sometimes it's not every data we pick from database, right? And sometimes data issues everywhere, right? Data issues everywhere, inconsistency in data, and all of those things happen. So maybe, so we are just trying to point that there is a possibility, right? There's a possibility that on the foreign key is empty. It's not. It's a possibility. It might happen. But we are not saying that is best practice, right? So come from the angle where Mr. Ibam is talking from, on the angle of database design, optimization, structure, and everything like that. A foreign key too should not be empty, should not be null. But this does not mean that it does not happen, right? It happens, right? But we are not saying that is best practice. Because I hope it's clear what Mr. Ibam is saying and what I just said. Is it clear, guys? Mr. Ibami, I'm not off point. Okay. Okay. Thank you. So now, one cardinality and many cardinality. Now, when we say one cardinality, what does that mean? Let's take an example of your dimension table. Your dimension table, right? For example, the product table, don't forget that it's a unique list of products, right? Product ID, product name, product ID, product name, product ID, product name. Now, the cardinality on your dimension table is a one cardinality. It's a one cardinality because what you have is a primary key and is a unique list, no duplication, right? So we call that kind of cardinality a one cardinality. Let me go back to that my Excel example that I used. Let me just go back. In it. We are almost done, guys. We are almost done. We are not wasting anybody's time. So now look at the product table now. A unique list of products and their names. Customer table, a unique list of customer and their names, right? Now, on the product table, the cardinality here is going to be one cardinality because what we have is a unique list and there's no duplication. Now, by the time this product ID gets to the transaction table, which is the sales table, now, right, it becomes a foreign key on this table. It means that it can have duplicates, right, on this sales table. The cardinality here is going to be one cardinality. Yeah, it's going to be many cardinalities, sorry. So one cardinality here because this one is unique. Many cardinality here because this one involves duplication. Shall I come again, guys? The product table is the dimension table. A unique list of products, no duplication. Now, the primary key, the cardinality of this primary key on this table is a one cardinality because it's a unique list. Now, by the time the product ID gets to the transaction table, which is this sales table, right, the product ID becomes a foreign table, don't forget that, and the cardinality is going to be many because there's a duplication of unique values on this table. So now, by the time I'm now creating relationship between the product table and the sales table, is now going to, if I'm looking at it from the product table to the sales table, is going to be a one-to-many relationship. If it's from the sales table to the product table now, it now becomes a many-to-one relationship. So it's the same thing, depending on what table you are looking, what table are you using to look at the other table, right? So the cardinality here is one, the cardinality here is many. Same thing goes to the customer too. A unique list of customer ID here, the cardinality here is one. And when it comes to the sales table, the cardinality becomes many. So we call it a one-to-many relationship or a many-to-one relationship. Is it clear to you guys? Is it clear to you guys? So now we've talked about two types of cardinality. We've talked about one cardinality. So anytime you hear one cardinality, it means that there's a unique list. It's a unique, there are unique values, right? There are unique values. But when you hear the word many cardinality, it means there's a duplication of the values that you have there, right? Now, this now brings us to the types of relationship that we have, right? Now you understand dimension table. Now you understand fact table. Now you understand primary and foreign key. Now you understand cardinality of relationship, which is many or one, right? Now, this now brings us to the four types of relationship that we have in between tables, right? We have one-to-one relationship. Now, can somebody unmute themselves and tell me in what scenario can I have a one-to-one relationship? Bolaji?
Okay, so the scenario we can have one-to-one relationship is if my customer ID, I do not have that 101 repeated twice. Had it been that Y14, I have instead of 104 there, I have 105 there. Sorry, maybe I'm trying to, maybe you have another entry, maybe 106 there, sha, that is not 101. So I'm going to have one-to-one relationship in such case.
So it means that from both tables, there are unique values here, there are unique values here, right?
Exactly.
Thank you very much.
Yes, exactly.
Thank you, Bolaji. Frank?
Okay, thank you, sir. Yeah, the situation that warrant us to have one is to one relationship. If it warrant us to connect the, if it warrant us to connect. Yeah. Hello, can you hear me?
Yeah, we can hear you now.
All right, sir. So if it warrant us to connect a dimension table to another dimension table, it warrant us to have one-to-one relationship.
Frank, I wouldn't accept that really. Because it's not ideal to do that unless you are being a snowflake schema.
Yes, in that case, yeah.
Okay, in that case, I accept. I accept in that case. Okay. Who again? Adiola.
A situation one can have one-to-one relationship is maybe, for example, you hold a ATM card. Yes, a person hold a ATM card can have one-to-one relationship with the ATM because the ATM belongs to that person, not nobody else. Or for example, a person has a security number, nobody share the security number with the person. He only has the only security number with him. So that kind of example we can narrate it as one-to-one relationship, no duplicate. Only holds the.
I don't seem to get your example very well. Can you re-explain it?
Okay, what I mean, one-to-one relationship means that a person can have a relationship with a particular entity. Like, for example, a person can have a unique ID related to a security number, and nobody else will have that the same security number. It's only to be the person only.
Okay.
And there won't be any duplication. So one customer can have a unique identity, and nobody can share the same number with him. So that's kind of example. It's a one-to-one relationship. One ID to a particular person. Nobody can share it.
But what you just explained now is explaining primary key.
Okay.
What I actually mean is a one-to-one relationship. One cardinality here, one cardinality here.
Okay, let me give it this way. Maybe a customer is making an order online. So yes, so it is making an order online. When you place an order, he has a customer ID. But when he's trying to make an order, he has an order ID. So the particular order that he's making at that present moment is one-to-one.
Okay, don't worry, Diola. Thank you. But you're not really explaining it the way I want it. But don't worry. Thank you for trying. Thank you. Okay, let me try Shegun.
Okay. Thank you very much. So the example I will give is as regards employees.
Okay.
So let's say a particular finance company that deals with loan. So maybe it's the policy of the company that as an account officer, you should not disburse more than once in a month. So we have the employees table whereby we have unique, that is a kind of dimensional table. Then on the disbursement table too, it will show an account officer and what the account officer has disbursed. So when you try to connect the employees table with that disbursement table, so we can only have one account officer on that table for a particular month. So an account officer cannot appear twice. So it means that the account officer will be unique. So when you try to connect it with the employees table, so there will be a one-to-one relationship because
that example is good, but it has one limitation. So you only limited it to per month. It means that when I am like a new month, right? When we get to another new month, since the account officer can disburse once per month, it means that the account officer is still going to show in another month. So it's not still unique.
I'm looking at it from perspective of just a month, just to reduce.
Just a month. An account officer is just a month. Okay, no problem. Thank you. Any other person? Any other person? Any other person? Any other person? I want new people to talk now. This is what I've talked before now. Or should I call names? Caleb, are you there? Caleb, can you give me an example where I will have one-to-one relationship?
Come in.
Yeah. Are you there, Caleb? Because we don't have much time.
Okay, can you hear me?
In a few minutes. Yeah. Oh, yeah, Caleb.
Okay, within the case of your order ID within this product table and your dimensions table where you have the customer ID. Sorry, that's okay.
Sorry, I didn't hear that word.
So I want to now join the.
We can't hear you. Don't worry, Caleb. There's network issues on your end. Don't worry. Don't worry. Okay, I don't want to waste time, right? Let me just Ayodeji is raising up his hand. Ayodeji. Let's make it snappy, please, so that we can leave.
Hello, can you hear me, sir?
Yeah, we can hear you, Ayodeji.
Okay, so I think from your explanation, sir, so when you have a one-to-one relationship is when you are actually linking two unique tables, like two-dimensional tables together.
Why are you using that example? What is it? Okay, continue.
Yeah, for example, like we have the product table and the customer table. Yeah, so I think we're actually linking the two unique tables together. So I think that was when
I think Mr. Yobami has to come in at this point. Mr. Yobami, are you there? Thank you, Ayodeji. There's something that we need to correct. Mr. Yobami, are you there? Mr. Yobami Adeleke. Please unmute yourself, please. Okay, Mr. Femi, allow Mr. Olufemi first before Mr. Yubam. Mr. Olufemi.
Sir.
Well done, sir. We can't hear you. Your voice is. Hello, sir.
I just want to say, with a one-to-one relationship,
okay,
I think I can use this as. Okay, can you hear me now?
We can hear you, but
can you hear me?
It was skipping. Yeah, we can hear you.
Huh?
Continue, sir. We can hear you.
Can you hear me?
Yes. Network issue.
Okay, can you hear me now?
Yes, we can hear you. Continue, sir.
Okay, so the example I want to use with regard to one-to-one relationship,
okay,
is when you are using, let me use this for example, a transaction reference for each transaction.
Okay.
In relation to the quantity to one relationship, because for each of the transaction to each of the unit of the product purchase. So we can use that for an example of one-to-one relationship.
Can you come again, sir? I didn't get it very clear.
Okay. I said a transaction reference for each transactions.
Okay.
Of a unit of a product purchase.
Okay.
In relation to each of the units. We can use that as an example of one-to-one relationship. So because for each of those,
okay, continue.
For each of those transactions,
okay,
that has each transaction reference is unique, and the quantity of the product purchase as well is unique to that transaction. I don't know. I'm just trying, sir.
Good try, sir. Good try, sir.
Yeah.
I need a very good. Okay, don't worry. Thank you, sir. You tried. Thank you. Okay, Mr. Yobami. Are you there?
Yeah, I'm here. Good evening once again.
There's something I need you to help me correct, sir. People are talking, when they are talking about one-to-one relationship, they are mentioning connecting two dimensional tables together. And that's not what I need. We can have a fact table and a dimension table, and it's one-to-one. So maybe you should give us like a scenario where we are connecting a table of dimension to another table of dimension. You can go ahead, sir.
What? I don't get your question.
A table of dimension to another table of dimension.
A table of dimension. What do you mean by that?
Like, I mean dimension tables. Dimension table.
Yeah. So a dimension
table. Another dimension table, yes.
That's basically what people have been saying, right?
Yes, I just need to correct something on that. That in what scenario is that going to happen?
Okay, so in modeling concepts, there are two approaches. Is either you are doing the star schema where you have your all dimensions tables relating to your facts table. So that's like your star schema modeling. The other approach is the snowflake, whereby you could have dimensions relating to dimensions. And I'll give us a practical example on that. So let's say I have a table called a dim products table. For people that are familiar with the AdventureWorks database, this Microsoft pseudo database that we always play around with, you have the dim products table. You also have a dim product category table. So you could do a relationship between dim products and dim product category based on the column in your product. There's a column in the dim product, I think it's called product category ID or something. So that in itself is actually even not a one-to-one relationship, because in the product category table, column in the dim product table, you could have three products all being in the same category. So that column in itself, it's still it allows duplicate basically. So you could do a relationship from that table, from that field in that table to the primary key in the product category dimension to relate the two dimensions. So that kind of relationship between dimensions is acceptable.
But it's not still one-to-one.
Yeah, it's still not one-to-one.
Exactly.
But I think what people are saying, the one-to-one people are saying is, for instance, I'm trying to relate cost with a team cost table, for instance, a cost dimension table with student table. Maybe even that you might still not get it one-to-one, because you could have multiple students enrolling for the same course. You could have the same course being enrolled by multiple students, vice versa, right?
Okay.
But now to speak to one-to-one relationships,
yeah,
this basically is best handled in the database level, right? And that is a condition whereby maybe in your transactional table you have so there's what we call the unique constraints that you could apply on columns in a table that allows such that in that column you only have one instance of a value. So once you record maybe 1 into that field, another row cannot come in with the value 1 into that column. It's going to accurately reject it. So based on that, you can then do a relationship from that field in your facts table to maybe a primary key in a dimension table. And there you can now have a one-to-one relationship.
Okay, thank you very much, Mr. Yobami. So what we are trying to say is that we are not saying that you can't connect two dimension tables together, right? Of course, if you are building a snowflake schema, which we are still going to talk, that's like the third section we are having. That section is basically is just on data modeling that we'll be explaining in that section all through. They're not writing any DAX or anything, it's just on data model, right? We can have a relationship between dimensions, especially when you are doing a snowflake schema, but that does not automatically mean that that is a one-to-one relationship, right? I'm just saying more emphasis on what Sayobani said. Now, when we say one-to-one relationship, it's very simple. We are only saying that on this table, there are unique values. So the key you are using to connect tables together is unique on table A and is unique on table B. Simple, nothing complex. On table A, the list of IDs is unique. On table B, the list of IDs is unique. Right? It doesn't matter whether it's between a fact dimension table or it's between another dimension to another dimension. So far, this table A is unique. Table B is also unique. That's what that's what is a one-to-one relationship. I hope it's clear to us, guys. Right? Don't worry. In the other section of the data modeling section, we'll talk more on this data modeling very well, because all what we are used to is just Snowflake and Star. There are many types of modeling that we'll explore in that session. So not to waste time, we have one-to-one relationship, we have one-to-many, which I explained before, we have many-to-one, and we can have many-to-many. So how can we have many-to-many? And is it ideal to have many-to-many? So let me ask the Abbas in the house. Can anybody give me an insight to that? In what scenario can we have many-to-many? And is it ideal? Mr. Obama, you can still say something here. Many-to-many relationship. If it's not clear to you, don't worry. You will be clear by the time you get to the third section. Many-to-many relationship. In what scenario? And is it ideal? Those are the two questions. Godwin.
Can you hear me?
Well, you have a noisy background though. And that's not appropriate.
Oh, okay. Let me.
Bolaji.
Okay, good evening.
Well done, sir.
Sorry for greeting again. With my own level of understanding, I might be corrected. I don't know. It's not ideal because normally in dimension tables are always kind of a unique entries in dimension table, but it's only in fact table that I feel that we can have duplicate. But I might be wrong. I don't really know where exactly we can have a many to many. I don't know that, but I don't think it's ideal. That's just my response. I don't think it's ideal.
Okay, thank you very much. Mr. Akinloye, can you say something? Is it ideal to have many to many relationship, and in what scenario can we have it? In what scenario can we have a many to many relationship? In what scenario? Okay, Priska.
Okay, good evening, everyone.
Good evening.
Okay, I want to use instance for, let's say, you have a logistic company,
okay,
and you have the drivers, and you have the other item. So for the drivers, you can actually have many to many relationship, because they have orders that they will pick and have to deliver them. So for a driver can have more than one order like that. I don't know if that makes sense.
Continue.
So for me, that's for me. It's like it's a scenario where you can have many to many relationship.
So explain table A and table B. What do you have in table? What do you have in table B? That's making you have many to many relationship.
Okay. Let's say for table A now, you have the names of the the riders. You have their names and everything about the riders, their information. Table B, you have the other items.
Is that the riders table?
No, there's a riders table A.
Okay, that's where you have the unique list of all the riders, Abby.
Yes.
Okay. Continue.
Then there is other table B, items being picked to be delivered. And so am I making sense? Okay. So you the rider now, the one rider can have relationship.
Okay.
Like picking items from the other table. And also, I think yes, I think yeah.
Okay.
So yeah, you're saying okay. I think so many relationships can come from getting items and delivering the item. Because
okay. I was about to say that. So you are saying we have the order table and the sales table.
Yes, exactly.
So we have order table and sales table.
Yes.
So what keys are you now connecting to each other?
Okay, the key that you're connecting to each other, it's actually the order ID.
The order ID from sales and the order.
Yes, exactly.
Okay, so is it ideal to do that by standard?
Is it ideal to connect the other ID?
To connect other ID that is foreign in terms of it has duplicates, and it has duplicates in the other table too. Is it best practice to connect them together as per many to many relationship?
Okay.
Don't worry. If you don't
I'll
know,
say yes. If I'm wrong, you can actually correct me.
Okay.
I'll say yes. So,
Why?
but if I'm wrong, because it helps you it shows the relationship. It shows the relationship.
We are almost 2 hours. Okay. Thank you very much, Priska. I want the Agbas in the house to say something about this before we go to the data modeling class in the third session. Somebody's already complaining that we are almost 2 hours. Sorry about that. Hey. Somebody, please say something. Many to many relationship. Is it ideal? Is it ideal?
Let me speak.
Please speak, sir. I've been waiting for you since. Yes.
So, I will not say many to many relationship is ideal or not ideal.
Okay.
So why I'm saying this is because sometimes you have tables that are built, you have data in two tables, and you just need to relate them. Then you now do your relationship and you now realize that, oh, there are duplicates on both ends.
Yeah.
So at that point, how do you proceed as an analyst? You need to relate these tables to do your analytics. So that's what I'm saying. It's not, and if you look at it from the concept of Power BI, that option is there for you to create a many-to-many relationship. So yeah. I'll be biased to say it is ideal or not ideal. So I'll just leave it at the table for everybody to decide. But what I usually do when I face such challenges is, yes, I have a many-to-many relationship, but I would rather not create a many-to-many relationship and use. So what I would rather do is create probably a calculated table that just gives me unique values from from one of those two tables.
Okay.
Or maybe from the dimension that is feeding into that field in my transaction tables. That's from my dimension table, if I have one. So with that, I could create like I think it's called a link, or is it a bridge table kind of. So I now have that unique table in between my two tables that I want to relate. So instead of having a many-to-many directly, I have a many-to-one, a one-to-many. I don't know if that makes sense to us.
Make a lot of sense, sir. Make a lot of sense. Please, we have to stop the class for today because we spent more than the agreed time, right? Because we have a lot to discuss. So about data model, right? Even if it's not clear to you, don't worry. Our next section is about Power Query and transformation for next week Saturday. Then we'll be having data model in our third session, where we'll discuss the different types of model that you can build with Power BI. Thank you very much, everyone, for attending today's